Hi there. I hope you can hear me. My name is Austin Dial, and it is Thursday, March 24th at about 9:14 p.m. This is my assignment 7 submission. So we're going to go ahead and get started here, running the executable. So just as it's specified in the assignment, it asks us for a number. Let's just start out with 5 here. Now, when we're representing a positive number using negative representation tools such as sign magnitude, 2's complement, and 1's complement, those numbers are going to be just the same as the binary representation of the decimal input. So not really anything very exciting there. And the program, of course, does print the hexadecimal and the octal equivalents for both the sign magnitude, 2's complement, and the 1's complement representations. And we can confirm that this code works simply by using this handy-dandy calculator here. So if we input 5, we see that the binary equivalent is 101. That's all confirmed. Because it's a positive number, the sign magnitude, 2's complements, and 1's complement representations should equal the binary, which they do. And the octal representation and hexadecimal representation is 5. And that makes sense because the number doesn't exceed the base. So they're both going to be the same because hexadecimal is still counting 0, 1, 2, 3, 4, 5, octal 0, 1, 2, 3, 4, 5, and octal won't change until you reach 8. Hexadecimal until you reach, well, really 10, and then it will switch to A. So nonetheless, let's just input something a little bit more exciting. Let's give it a larger number. Let's give it something like, I don't know, 156 sounds cool. Look at that. Now they're all still the same. Let's go ahead and just confirm in terms of the negative representation tools, sign magnitude, 2's complement, and 1's complement are all equivalent to the binary. That's what we want to see. Now let's just confirm it with the handy-dandy calculator here. Our input number is 156. And that works out to be 234 in octal, base 8, and 9C in hexadecimal. And that looks confirmed here at the bottom of our output. Okay, so what about negative representations you're thinking? So let's go ahead and just input -6. Cool. Now -6 in binary can't be represented by this calculator, which makes it more obsolete than my code, which is pretty cool. Not to say that my code's obsolete. It's pretty cool, but I just like to see that the program that I wrote has more utility than the included Linux calculator. That's pretty awesome. So the binary equivalent is 110. Of course, it's just 5 plus 1, or 101 plus 1, which carries over to 110. That's great. And then the sign magnitude representation, of course, should be the 110 with a bit at 1. Hope I just tried to highlight, but I can't do that. There we go. To represent that the number is negative. The 2's complement and 1's complement representations will have a lot of 1s at the beginning because they're all weighted, of course they're going to be different. If we pull up let's see if I can get my browser in here. Let's use, and I was using this to research. I ultimately didn't use bitwise operators, but let's do 2's complement calculator. This is how we can confirm it. I could just, of course, do it by hand, but I don't really want to kind of throw it in there. It doesn't sound like fun. Yeah, that wasn't right. Yeah, if it's going to give me this much trouble, I probably should have pulled it up beforehand. There we go. Sorry about the wait there. Alright, so our input number is -6. So let's go ahead and input -6 here. It's going to convert it into 2's complement. In that 2's complement, let's switch the number of bits to 32. Calculate that again. Woo! Look at that. A lot of 1s there. And it looks like the 1s end with 010. You can look up here and say, well, look at that. 010 for the 2's complement. Now you're thinking, what about 1's complement? Let's see what we got here. Go. I'm very thorough. I like to confirm everything if I put it in there. Alright, our number, if I recall correctly, was -6. Number of bits were 32, and here we go. Once again, it's all 1s, not a surprise there, and ends with 001. Look at that, 001. So it looks like it's working. And of course, when we convert this into, or either of these 2's complement or 1's complement, into a hexadecimal or even an octal number, it's going to be rather large. And consequently, we can see here that the hexadecimal and the octal numbers are consequently very large, and that's great because that's really what we would expect. Let's give something larger. Let's say negative 256. Hey, that should be fun. Oh, gave it two negatives there. That would have been quite the fall through. Ooh, you can't see it because it's up there, but my processor spiked a little when I entered that, which is exciting. Okay, so let's represent negative 256. See that our output is correct here. Negative 256, 32 bits, pardon me. Okay, good. Looks like we've got a 0 in the 9th place using 1's complement. That's 4, 8, 9th place. Look at that. That one's working. Let's go over here, negative 256. Oh. Looks like here the 1's don't begin until the 9th place. Nice symmetry there. 4, 8, there we go. And just like you would expect, this is the binary representation. Let's confirm that with the calculator. That looks like 256. 8 zeros and then 1 1, 4 8 1, and of course the sign magnitude just has a 1 up there to indicate that it's negative. And as I said before, when you throw these in, it'll be a very large number because all of these 1's are weighted, and that throws it in there, which makes it appear very large. And of course the hexadecimal, I don't know if you can see that in there, but they all check out, which is exciting. So yeah, I hope you enjoyed. Hope that it makes sense and everything. Enjoy the code. I didn't write a dissertation like I normally do. Actually, I just included it in the code. You mentioned in assignment number 1 when I submitted it that I didn't necessarily have to just format it into a PDF. I could just upload the C file directly. So I decided to do that, but to simply put a giant letter in there that's explaining everything instead. So I hope you enjoy. It's kind of funny too because it's late at night and I'm getting pretty sassy, which means that I threw in a couple of jokes there. But I hope you enjoy. I hope to make the process of grading a bunch of people's C code a little bit less tiresome. Anyways, see you tomorrow for the next assignment. Bye bye.